Trigonometric functions on the unit circle. Here is the unit circle. It's a circle with radius 1. Here is theta, is the angle that opens up on the positive side of the x-axis and ends up at the point xy, which is the point on the unit circle. We defined y to be sine of theta and x to be cosine theta. We are using those two building blocks of the trigonometric functions to have the additional 4 others. Tangent theta is sine theta over cosine theta, which is also y over x. Cotangent of theta is cosine theta over sine theta, or 1 over tangent theta, which also equals x over y. Secant theta is 1 over cosine theta, or 1 over x. Cosecant theta equals 1 over sine of theta, also 1 over y. Because the x and the y's are in a unit circle, then it's clearly that all the values of x and y's are between -1 and 1. We get that sine theta and cosine theta are always greater or equals to -1 or less or equals to 1. But also using the Pythagorean theorem, we get that for any point xy on the unit circle, x to the power of 2 plus y to the power of 2 equals 1. Or in our case, we can apply that and get that sine to the power of 2 theta plus cosine to the power of 2 theta equals 1. The graphs of the sine and the cosine functions. Here is the graph of y equals sine theta. In parallel, we are going to draw now the graph of y equals cosine theta. Please pay attention. The graphs of sine theta and cosine theta are continue forever from -infinity to infinity. This is only one part. The domain of the two functions is all real numbers. The range is all values that are greater or equals to -1 or less or equals to 1. We also recall that sine to the power of 2 theta plus cosine to the power of 2 theta equals 1. The graphs of the sine and the cosine functions are different only by a horizontal shift. If you look, they have exactly the same shape. I will draw them together and you will see the shift. We are now going to see the trigonometric functions on the right triangle. We are going to label theta as one of the angles which is not the right one. Here I choose this to be theta. I'm going to label the sides as A, B, and C. When C is the side which is against the right angle. In this case, theta has to be greater than 0 and less than pi over 2. Sine theta now is going to be A over C, and cosine theta is B over C. Now we are going to use the sine of theta and cosine theta to express the other trigonometric functions. Tangent theta is sine theta over cosine theta, which is also A over B. Cotangent theta now is going to be B over A. Secant of theta is a reciprocal of the cosine theta and it is C over B. And cosecant of theta is the reciprocal of sine theta, so it is C over A. We want now to see the connection between trigonometric functions on the right triangle and trigonometric functions in the unit circle. If I'm going to take this triangle and put it somehow in the unit circle, I will need to take that the length of C is 1. So now instead of C, we know that this is of length 1. In this case now, sine of theta is a, and cosine theta is b, and all other trigonometric functions now are going to be tangent theta is a over b, cotangent theta is b over a, secant of theta is 1 over b, and cosecant of theta is 1 over a. Two special triangles. Here is the first one. As usual now, because we would like to identify these triangles also with the trig functions on the unit circle, we will take the longest side to be 1. In this triangle, as you can see, the two angles which are not the right one are pi over 4. In this case, we know that this is an isosceles triangle and a equals to b. Let's apply Pythagorean theorem. a to the power of 2 plus a to the power of 2 equals 1. 2a to the power of 2 equals 1. 2a to the power of 2 minus 1 equals 0. Write this as product of term and we get that. We get that a algebraically can be plus minus 1 over square root of 2. But as you can see, this is the length of the side of the triangle, so it has to be positive. So I can conclude that a equals 1 over square root of 2. Using this special triangle, I can get that sine of pi over 4 equals cosine of pi over 4 equals 1 over square root of 2. Obviously, by knowing that, I can figure out what is tangent of pi over 4, cotangent of pi over 4, cosecant and secant of pi over 4 as well. Here is the other special triangle. This is a right triangle that the other two angles are pi over 6 and pi over 3. The situation now here that the smallest side is exactly half of the longest one. And because the longest side we take to be 1, that this one has to be 1 over 2. Let's now apply Pythagorean theorem to find out the length of a. a to the power of 2 plus 1 over 2 to the power of 2 equals 1. And we get that a is this. Don't forget, a has to be a positive number. Get that? And a is square root of 3 over 2. We can conclude now that sine of pi over 3 equals cosine of pi over 6 equals square root of 3 over 2. But also that sine pi over 6 equals cosine of pi over 3 equals 1 over 2. From this, I can conclude everything about the other trigonometric functions at pi over 3 and pi over 6. Example, find tangent of 5 pi over 6. Because 5 pi over 6 is greater than pi over 2, we will use the right triangle in the unit circle. Here is the unit circle, and inside we realized that because the angle is 5 pi over 6, I can actually insert the right triangle here, and I have that. To find the tangent of 5 pi over 6, I need to find the sine and the cosine of 5 pi over 6, which is the x and the y's of the point xy. So this is the triangle that was in the unit circle. You can see, first of all, that the value of y is 1 over 2. What about the value of x? The value of x is radical 3 over 2, but it's negative because, as you can see, x is negative in the second quadrant. So I get the tangent of 5 pi over 6 is sine of 5 pi over 6 over cosine of 5 pi over 6, which is just y over x, which is 1 over 2 over negative square root of 3 over 2, which is negative 1 over square root of 3. We can also do this directly by looking at the triangle. If I look at the triangle, I just get that because I know that the tangent is the one that is across the angle, which is 1 over 2, over the one side that is adjacent to the angle, which is negative square root of 3 over 2.